So, gosh, when did it all begin? Clear back, gosh, maybe as far as 2013, 2014. Several of us would get together at the conventions each year. One's going on right now, some great talks on the day one. And we would talk about, the barrier to entry for developers for more Amigans on the new Amiga 1, new-ish Amiga 1 platform. Previous boards were solid, they were powerful, they could run multiple OSs, and frankly had some pretty spiffy cases. But they started at like $1,500. So a lot of us, myself included, were kind of staying on the sidelines, just kind of doing emulators, etc., hoping for a better board. And Trevor eventually was coming up with the Tabor, which proved to be, a bit of a long process in hindsight. A lot of tweaks. Bit of a learner Amiga 1 board. Lower specs, but tuned for OS4. Priced for more the hobbyist. Small batches instead of large batches with long, deadlines and difficult part runs. So, the 1222, codenamed Tabor, it was intended to bring all of this to a more accessible level. Ultimately, we actually strived to not be a $1,000 price tag for the board, but more like $600, but that didn't quite work out. We used some parts that were fairly available, although it's the first time anyone's really done this for a motherboard with an operating system like this. The Freescale P1022, the FPU is a little bit weird, which has made dual booting and whatnot challenging so far. However, they're shipping. We've built them. The OS has matured dramatically. You can see a kind of developer project going on over here. Lots of software, although some things need recompiled for the recent updates, I think. And, today, what I want to do next is to take you all through some examples of developing both from native Codebench, which is kind of what's loaded up over here, except I'm running the program, as well as doing the cross-compiling natively in your Linux or Windows workstations. So, without ado, let's enjoy the A1222. Okay, in this next bit, we're going to take a closer look at some classic examples of the AmigaOS4 SDK. In this case, a simple thing called Test App C, originally written by Hans-Jörg Frieden. Then I'll demo how you can cross-compile this in a Docker container. Basically, this code demonstrates a classic reaction GUI layout, multiple tabs, a mix of choosers, radio buttons, and gadgets. Key concepts include the make window, the enum functions, the auto initialization feature, which has plagued me in my learning quite a bit. As we get over to the compilation stage, it's going to be kind of easy, really, but really the point is that this portability will allow you to do projects like this and at least get through the main compile routine most of the time with your normal modern hardware, not necessarily directly on an Amiga workstation. So maybe you don't have an Amiga workstation to test things on, but you've got C talent and you want to help out with the community and go through and try to compile things. In general, I mean, I've seen a few cases, but what's built in the cross-compiler will run. Sometimes when I've been doing experiments with AI, it'll reference things that'll compile, but it won't actually execute properly at the end. So you always want somewhere to test them. What we're going to do after this segment is we're going to go through and basically FTP the file down using Pete's FTP into the Amiga machine and take a look at things from that perspective. And after that, we'll go over CodeBench a little bit with some of the recent examples I've found. So, getting into it. Of course, Visual Studio nowadays, I mean, we are talking about GCC-based programs, right? So, you know, you can go through and work on your code. You can even do things like with the Copilot, although it's a little bit squirrely because this topic's a little obscure for it. But you could technically explain your code. You could allow it to refactor it and then retest. Those are things I'd trust. For the most part, though, it gets lost pretty easily writing code. So we have our source code here. We got our make file, right? What we expect to see happen. We've got our README. We've got a compiled prior, right? We're just going to actually get rid of that real quick. Oop. Move to trash. And then, I mean, some of you can rig up your inline terminal here to do this next step. Fine. I'm going to just go ahead and use my Docker container. So, using the Docker container. There is a gentleman, I'm thinking it's Rolf Kaufman, who has put together a darn spiffy SDK Docker container. So right here, of course, my Linux host are. So we simply need to enter. I mean, realistically, you could actually just do the whole command path and everything in one step. You could modify this mount point here to just be root make all, right? By doing this mount point, we're syncing the local file system, in this case of my Linux box, with the container file system of /projects. And then we're picking the Docker container image that we want to run, and of course we're entering into a bash shell. Oh, we do have to be in the Docker group or use the infamous sudo. And then once we're in here, somewhat anticlimactic. Well, let's try this. Maybe that'll be a little more dramatic. Oh shoot. Why no? Oh, well that's interesting. In the wrong spot. Projects, SDK, examples, GUI, test. Right. Let's try that one more time. Okay, so what happened? We compiled the test app. You can see the timestamps today. Day 2 of the show, by the way. You can see the test object. You can make it clean. There's no rule in the make file right now, but so for in our case, you can just rm -f test app and test app o, and then run the make again. Right? The debug's just letting it be a little bit more dramatic about the output. And there you have it. next step, we're going to go switch over to the Amiga side.